So here's the question. Find an equation for the ellipse whose graph is shown. So I know that I have to come up with something like this, because this is the equation of the ellipse. Okay. I do not know this length. So I don't know what this is, and I don't know what this is. But I do know this number for sure. How much? Say it again.
B3. 2. 2 squared is 4. Make a number B8 squared. Oh no, we're doing it 5. 4. Squared.
That part I know for sure. Because it goes to the vertex of 4, and to the vertex definitely of -4, and that is given in the problem. This is given to us in the problem. Okay? So let's go back to the book again just to make sure. See?
Yeah.
There is no question that this must be 4. And there is no question that this must be -4. Although it's not indicated. Clear? Okay, perfect. I also have, so I have the major axis going to +4 and -4. So definitely because it's on the y-axis, this must be the number that is bigger. Okay, this one I don't have yet. If I manage to determine this, I'm done. Because that's all I need. I need to determine these two numbers and I'm done. I have the equation. I am, however, given 0, c. So c equals 3. And I know that c comes from a square root. And it has to be the square root of the larger number squared minus the smaller number squared. And what will I have under the square root?
4 squared.
Right, which is 16 minus this, which I don't have yet. But I know that c is 3. So here's my equation then. What will I obtain from this equation? What is the only variable in this equation? A. So once I have A, I will put it here, and I'm done. What type of equation is this? And how do I solve it? Right, it's a radical equation, very good. Or square root, you're fine. So what do I do now?
Square both sides.
Very good. So 9 equals 16 minus A squared. I will bring A squared and I will bring 9. So A squared equals 16 minus 9, which A squared gives us what? 7. That's all we needed. Can anyone dictate the equation of this ellipse?
Squared over 7 plus y squared over 16.
We were not asked to identify anything else. We were not asked to determine the length of the minor axis. We were not asked to find anything else. We're asked to, yes, Stephen?
Is the foci? How do you say that?
Foci, the plural, yes.
Is it always 1 to 1? Like, are they? Would the other one be 0, -3?
Yes,
Okay.
yes, they have to be symmetric, mandatory.
Thanks.
Yes, they have to be symmetric. If one of them is found at 0, 3, the other one has to be at 0, -3. If one is on this side at -2, 0, the other one is at 2, 0, because it's a symmetric figure. Anything else before we look at one from 45 to 47? Now, 22 I think looks interesting. It's up to you. And any problem from 33 through 44 looks interesting. any picks, or I will?
You think that one?
Okay, as I said, 22 caught my eye, and also 40 caught my eye. You choose. Very good. So in 22 we have 20x squared plus 4y squared equals 5. Find the vertices, foci, and eccentricity of the ellipse. Determine the length of the major and minor axis and sketch the graph. Where's my starting point? I have to. Without having one on the right-hand side, I cannot identify anything about the ellipse. So 20x squared over 5 plus 4y squared over 5. I would simplify. And here's what I have to do. Let me write it first. That's why it caught my eye. It's awful. Absolutely awful. I'm not going to graph this one. I'll let you graph it. So here's what I need to do next. The top has to be completely clean. It has to be 1x squared and 1y squared. That's the equation of the ellipse. 1. So when I flip this, I get the 4 over 1. So that's how I identify the a squared and b squared. Same thing here. 5 over 4, when I flip it, I get 4 over 5. But it has to be completely away from x squared and y squared, otherwise I won't be able to identify a and b. So now, which one of these two is bigger? And because of that, I know exactly whether it's going to be on the y-axis or on the x-axis. Yes, so will it be on the y-axis or on the x-axis? Yes. So major axis twice so this is the a squared and this is the b squared. So twice I have to take the square root here. The square root of 5 over 2 will be the square root of 5. Twice the length and the minor axis is twice times the square root of this. I can quickly determine the c, which is the square root of 5/4 minus 1/4. Look, something nice in this ellipse. So it's 4 over 4. Yes. That is c. It's not the eccentricity. The eccentricity is c divided by a. 1 divided by the bigger of these two, which is the square root of 5 over 2. So it's 2 over the square root of 5. It must be a number less than 1. So when I plug in 2 and divide by the square root of 5, I get 0.8944. So the eccentricity, 0.8944. Quite eccentric, right. Okay, so now the foci, F1 and focus F2. Are they on the x-axis or on the y-axis? Yes, if they are on the y-axis, then the first coordinate must be 0. And the coordinates are always 0, comma c or 0, comma negative c. But how much is c?
1.
Yes. So it's positive 1 and negative 1. That's nice.
one right first?
No. Actually, your book presents them like this. 0 plus or minus 1. So presents them together. Okay, so let's go and check and see that we answered all questions. Find the vertices. Okay, we did not find the vertices. This is not the graph. I can't graph the square root of 5 over 2. So this is the square root of 5 over 2. This is negative the square root of 5 over 2. And this is 1/2, and this is negative 1/2. However, the vertices are where the major axis is, basically. I would not consider these vertices. I would just consider these vertices, because the other ones are kind of flat, right? So that's, okay. Foci, yes, we did. Eccentricity, yes, we did. Determine the length of the major and minor axis, yes, we did. And we sketched, no, we didn't. I just, yeah, but it's not really, okay. So let's look at problem 40 now. Is that okay?
Just real quick.
Yes.
Square root of 5 over 2, that's
From
not
here.
A or B
Yes,
squared.
yes, it's the bigger one. So I have to take the square root from this, because this is a squared.
Oh, it's already squared.
Always. It's always in the formula, is always squared.
Okay.
You have to take the square root to determine a.
Oh, gotcha.
That's why we put 16 in here and not 4.
Right.
So the formula, or I should say the equation of the ellipse is x squared over a squared plus y squared over b squared equals 1. So that's why this one, so this is 4, and now in the equation is 16. And that's why when we got a squared equals 7, we did not take the square root from it, because it has to be squared. Okay. And I think after this we can look at one of those problems and then we can stop. I think we beat the ellipse quite nicely. Okay, 40. We are given endpoints of minor axis, 0 plus or minus 3. Endpoints, minor axis. Distance between foci, 8. Find an equation for the ellipse that satisfies the given conditions. Oops. Okay, so first thing I'm looking at 0 plus or minus 3. If the foci are 0 comma plus or minus 3, that was a perfect question you had, Paul, because that's how the book shows it, instead of presenting them like that. So if I know that the coordinates of the foci are 0 comma 3 and 0 comma negative 3, where is the major axis then?
X.
Or wait, that's the minor axis.
Yeah, that's the minor axis.
Okay. So that's yes, the endpoints of the minor axis.
So they're on the y-axis.
So if this is the minor axis, 0 comma negative 3, it means that it is indeed on the x-axis. Very good. So I'm going to plot them here, which means b squared equals 9.
Right, okay.
So I already know that x squared over a squared plus y squared over b squared equals 1. And this is clearly 9.
Yes.
So I took care of this. Now I'm also told I do not know what is the major axis yet. So because I do not have, once I have this, then I'm done.
Yeah.
So I don't know where the vertices are. Once I find out, then I'm done. Good, but I do know that, let's say, the distance between foci is 8. Well, 1, 2, 3, 4, and 1, 2, 3, 4 for sure. Because one has to be, so this is F1 and this is F2. So if the distance is 8, it means that the distance between the two foci is 8. The distance between one of them and the origin, because we are not talking about the shifted conics yet, must be 4.
Yeah.
So then this must be 4 comma 0, and this must be negative 4 comma 0.
Mhm.
Knowing that, what do I know immediately?
A squared is 6.
Yes, I know C, which is the square root of a squared minus 9. And I know that a squared must be bigger than 9 because of what we just established and because the ellipse is on the x-axis. Since I know that this is 4, then I have 16 equals a squared minus 9. So therefore, a squared must be
25.
very good. Right? Okay. So can anyone give us the equation then? Yes? X squared over, that's it, plus y squared over 9 equals 1.
What does C equal again? I'm so sorry. I'm getting confused.
Yeah, I
Is
guess.
C equal to 4 because
See? Yes, because I am told that the distance between the two foci is 8. So it must be the case that the distance between one foci and the origin must be 4.
4.
Because these have to be symmetric.
Right.
So if this is 4, then the coordinates for foci 2, for focus 2, 4 comma 0. But this is C. And C, yes, and C equals the square root of a squared minus b squared. I created an equation. I square both sides. So it's 16 plus 9. I get 25 for a squared. Better?
Yeah.
Okay, so let's choose a problem from 45, 46, 47.
Isn't it easier to remember c squared is equal to a squared minus b squared because you have to square it again?
Correct.
If you
That's
just-
fine. That's fine. Absolutely. However,
I know c equals to the square root of all
right.
that, you know,
However,
so-
just remember the eccentricity
Yeah.
is not c squared over a,
yeah,
but c
yeah,
over a.
because you want to find the value for c.
Exactly. Okay, so let's choose one problem from there. Find intersection points of the pair of ellipses. Sketch the graphs, we don't have to do that, and label the points. Which one? Okay, 45. So we are given 4x squared plus y squared equals 4, and we are given 4x squared plus 9y squared equals 36. So from these, what we accomplished today is 1.8 and 11.2. That's the ellipse. Okay, and then next time on Monday we're going to look at a hyperbola and then come back to the parabola and finish that up. Okay, so obviously this is a system of two non-linear equations. We are told they're ellipses, so I know they're not even functions. Good. So any suggestion on how to solve this system?
Wait, what are we trying to do?
We're trying to solve for find the points of intersection.
Solve each.
I cannot.
separately?
Nope.
No?
Nope.
Together?
No. So here's what we're going to do.
You can't just get like the equation of each.
Nope. Here's what we're going to do. And you'll tell me why I choose to do this. Am I allowed to multiply both sides of any equation by -1? Because I say so?
Yeah.
Yeah.
Nothing, there is no change, right? Now I'm going to add. And then I have 8y squared equals 32. Okay, so I eliminated one of the two variables by algebraically manipulating one of the equations. I multiplied both sides of the first equation by -1 because it was convenient. And I realized that if I do that, x squared goes away. Okay, so now I have 8y squared equals 32. What now? What do you think I'm going to do next?
It's also y.
Very good. So then I have y squared equals, good. So then there are two options for y. Because it's quadratic, so then y equals,
2 or -2.
very good. Perfect. Okay, is this done? No. I have to go back and replace y squared by 4, let's say, in this equation. Doesn't matter which one you go back to. So 4x squared plus 4 equals 4. I subtract 4 from both sides, and I get that x squared equals 0. So then, in how many ordered pairs do these two ellipses intersect?
Which one did you put? Just 2.
Yes, and they are?
0, 0, 2, -2.
That's it. I like to show with the graphing calculator. I don't know, I don't remember if the calculator has that. Try to find under apps. I don't know if this one has it. No? Okay. Try to find under apps, conics. Your calculator cannot have it, it's too old. Mine is too old.
Mine's too old.
Maybe, yes. So let's go to apps. So let's try. I'm still sick. Conics, very good. Okay, so let's hit on 2, ellipse. And
Do you want
so we want,
Does everyone else have it?
Yeah.
you do?
Yeah.
Have it? So let's do,
Calculated.
which one are we doing? Is it on the x-axis? We don't know. Oh, yeah, let's choose one or the other. Let's go back to the previous, whichever. I don't know why the software doesn't have it. So under, yep.
Do you have this view?
No.
Yes.
Let me see if this calculator has it. Oh yeah, I do have it, and then but not on. Okay, so here it is. Okay, so I'm gonna go to ellipse, and let's say, can you show me which one we want to look at? Any pick? You want to pick?
Like x squared over 9 and plus y squared over 16.
So you wanna graph one with on the x-axis or on the y-axis? The red one is on the y-axis and the blue one is on the x-axis. Which one you would like to graph?
Blue's fine.
Okay, the first one. So A, in our case, agent K will be 0 because there are no shifts. So what do you want for A?
3.
Okay. But remember, because we are on the x-axis, this number has to be bigger than this number. So if you say 3 here, you cannot say more than 3 here.
5.
Okay, so you want 5 for that. And then, okay. And I want a graph.
Cool.
Alright.
Get a new calculator.
Oh, that's cool.
Not, you don't need it just for one little thing.
Just draw circles.
Good.